So it is an absolute pleasure to introduce Akira. こちらは松田明です。彼は日本から来ましたので、浅草日のオーガナイズですね。So we're not going to actually introduce him in Japanese. I think it would be funny to just keep going like that, but you won't know anything about him. He's fascinating, actually. He's one of the founding organizers, I think, of Ruby Kaigi and Asakusa RB. And Ruby Kaigi is the largest Ruby conference in the world. I think they had 800 attendees last year. And it was an amazing conference. If you ever get the chance, you should definitely go. Asakusa RB is also hosted near Ueno, there in Tokyo, every month. So if you get out there, you should stop in and say hello. Every week. Is it a weekly event? Oh my gosh. Every week. They're a little hardcore about their meetups in Japan. They take that seriously. So other things, like if you've ever had pages in a Rails app, paged events, that's probably Kaminari, that thing that he wrote. He also came up with the active args and action decorator gems, many gems. He's a core committer on Ruby and a core committer on Rails. Akira is fantastic. You should get to know him. He speaks English very well. He learned when he was on exchange in Zimbabwe, so he speaks with a little bit of an accent that you may not recognize. Okay, once again, this is Akira Matsuda-san. If you want to say it in English, it's Akira Matsuda, okay? All right.
So let me start. Cheers, everyone. I'm from Japan to talk at this conference today. Japan is, of course, the country where Ruby was made. Thank you. So we have Ruby in Japan, and we have good sushi in Japan, of course. And also, we have great sake in Japan. So, actually, I brought a big bottle of sake, which is really high quality, amazing sake. For you beer drinkers, so I don't know how we can share this, but let me just pass this to the organizers. So anyway, this is me. My name is Akira. Matsuda is my family name. You might be familiar with the Mazda spelling, which is spelled by a car company, I think. My GitHub account is a Matsuda. My Twitter account has an underscore. And on GitHub, I think I'm recognized as the creator of the Kaminari pagination plugin for Rails. Thank you. And active decorator and many other gems, which you can find from the repos tab over there. And some of you might remember that I once had a chance to speak here and then to introduce some of my gems at Ruby on Rails. I think that was 3 years ago. So this is my second time speaking here. Thank you very much, organizers, for inviting me this year. I'm very happy to be back again. Thank you. And on GitHub, you see, I'm a committer of Ruby, the language, and Rails, the framework, Haml, a template engine. And recently, I got a commit bid for Carrier Wave Uploader. I don't know why, but they gave me the commit bid. And I live in Tokyo, Japan. I'm the organizer of a local Ruby's group there named Asakusa.rb. So that's me. By the way, I realized the number 985. So thank you, 985 people, for following me on GitHub. That is amazing. It's nearly 1,000. So if you're not still not following me, you just can visit this page and click the follow button on top right. If 15 of you here do that, the number will be like, let me check. Can I refresh? Okay, I'll stop this. Thank you very much. Okay. So anyway, as a day job, I'm freelancing in Tokyo. I work for several companies there, and my talk today will be about one of my clients named Cookpad. So to begin with, let me show you the result of rake stats command on the Cookpad application. That shows you how huge the application is. This Rails app has 1,700 models, active record models, and the total lines of code is like 400,000 lines, which is crazy huge. The application depends on 276 external gem libraries. The website has 50 million unique users per month, which is like 1/3 of the whole population of Japan. And the website gets 15,000 requests per second at maximum. This record was just made last month, I think. And we used 300 Rails application servers to handle these requests. Our database YAML contains more than 1,000 lines, and our production Rails application connects to 30 database servers. We have 20,000 RSpec examples, and the application is developed and maintained by approximately 50 developers. The application is still actively developed and maintained. Like, we make 2,000 commits per month. And we regularly deploy the application more than 10 times per day. So, what is Cookpad.com? What do we do this? What do we do here? So Cookpad.com is a cooking recipe sharing site. It's like an SNS that users can post their recipes, and users can search recipes from the menu or by the ingredients, etc., etc. That's all. That's all, basically. And we stored 2 million recipes there. But you probably have never seen this website because the contents are only in Japanese. We're working on the English version from scratch. I mean, the English one is not the one I'm talking about today. I said we have 15 million unique users per month, which is like every Japanese who cooks actually uses Cookpad. And, and here's our philosophy. The application must be fast, as fast as possible. We're always aiming for this speed, like less than 200 milliseconds. And basically, we're achieving this speed. So, how do we achieve this speed? I think I read on the internet that such huge application doesn't scale for some reason. But actually, ours does. Our solution is we just let Rails scale. So, this is our strategy. Because the website is about cooking, it's not always busy. I mean, the axis, this is the actual request, number of requests. So the graph shows that the number of requests, the site becomes very, very busy around 5, 6 p.m. when every mother starts to cook for the dinner. And for the same reason, the second spike comes around at lunchtime. So I said we run 300 servers. Yes, we need that number of servers before the dinner time. But we don't always need that. Right? So our approach is we scale dynamically. We call the solution Cookpad Autoscale. For this purpose, we made this software. This is something similar to Amazon autoscaling, but our version has some clever kind of version locking system. So first, we make the Linux image disposable, immutable, and the system builds up the server when traffic increases, and the system automatically shuts them down when traffic decreases. Yes, we're doing this on a production server. This graph shows the number of the servers. You see the graph basically draws the same shape as the number of requests, right? So this way we control the way Rails scales, so that the users will never experience heavy load even before the dinner time, and the server fee doesn't cost very much. So I said we manage 300 servers at maximum, and we continuously deploy the application to those servers. And I hear people say deploying a huge application to servers is hard because it consumes a lot of time. So, shall we divide the application? No, we don't. So, are we using Capistrano? No again. Because for us, Capistrano is slow. Because SSH Capistrano uses SSH protocol, which is very slow for this purpose. So our solution is we made our own version of deployer, which is called Mamiya. This deployer uses another protocol called Gossip. Yes. And with this deployer, deploying to 300 servers finishes in a minute. Capistrano used to take like 20 minutes, so ours is faster than, like 10 times faster than Capistrano. And for more details, the author himself talked about this at some conferences like RubyKaigi and RubyConf. This author is actually a kid. This guy made this software. He's the youngest Ruby committer. He became a committer when he was 14 years old. He joined the company when he was 15. And last month he became 18, but still he's a kid. But he's a super hacker. So that is how we deploy. And next topic is database. As I showed you, our database YAML contains 100 and something lines of code. And I heard active record cannot deal with multiple DBs. So basically, we need to run 30 individual applications in order to connect to 30 databases. Is that correct? No. Active Record Base has a method named establish connection. And you can connect to any database using this method. But simply connecting from each table with this method will probably kill the databases because we have 300 servers, and this would bloat up the number of connections. So instead of and moreover, we're not just connecting to DBs, but we need to do something like master-slave switching or sharding or parallel execution. And what we actually do on Cookpad is master-slave. So how do we do this? I know we have we can find some gems on GitHub, but our solution was we made our own, which is named SwitchPoint. This is a very simple master-slave connection switch built on Active Record. And unlike other ones, this is very, very well written without any, like, if Rails version is larger than 4 or something. The architecture is, it creates a dummy anonymous Active Record model inside the plugin, actually connected to each Active Record connections, and switches between the connections on the proxy model. This is how to use the plugin. The finder takes the block with read-only block and with writable block. And inside these block, it connects to the read-only connection or writable database. Internally, the structure is like this. I just copied this from the README, so please consult the README if you want to know more. Anyway, the author looks like this, I guess. He's also a young guy. He's a freshman. And he made this plugin in one day. So he's yet another young super hacker in Cookpad. So the next topic is testing. We have 20,000 RSpec examples, and we heavily use Capybara integration testing. So running these tests takes 5 hours on my machine. But, we don't want to wait 5 hours until the test is finished. Actually, 10 minutes is our goal to finish the test. So, how do we do this? The only way is to shrink the application size? No. We made our own version of parallel RSpec executor. Initially, this was like SCPing the source code to the remote machine, which was named remote spec. This solution was initially made by this guy, Oidoksa. Right. And we open sourced this with another name. And we currently use this software for both CI, on CI server and on our local machine for RegSpec alternative. So the strategy is like this. It's distributed, remote execution, optimizes the test execution order, and it's highly fault tolerant. I'm going to explain about this later. And we use this kind of server, EC2 C3 8X large, it's a monster, which has 32 CPUs and 60 gigabyte memory. And on these servers, our 5 hours RSpec finishes in 10 minutes. Would you imagine this cost much? Actually, in fact, this is cheaper than any existing cloud CI solution. because we use spot instance, which means it's not always up, it's not always running. We use the server just when we're in need, running the RSpec. So it's very cheap. And here's another problem with testing. We used to use database cleaner, but because we have 1,000 models, it tries to delete from 1,000 models for each these 20,000 example, which is extremely slow. So we made our version of database cleaner. In fact, we do not use all these 1,000 models per each test. So why do we need to delete from all these tables? So this is our solution. We monkey patch active record, and we remember the names of the tables when inserting into the table, and delete from only those tables, which is sometimes like more than 100 times faster than database cleaner. This strategy was created by, again, Oidoxa, and I made it into a gem, so you can use this. And the next topic is migration. We do not use active record migration because we have so much databases and schema changes. So instead, we made our own version, which you can find on GitHub here. This is something like active record migration version of Chef or Puppet. And so next topic is how do we doing the prototyping on Rails? Like, we have 50 developers editing one single application. How do we avoid conflict on the application? We made our own prototyping framework on top of Rails, which is called Chanko. This helps rapid prototyping on Rails, again, created by Oidoxa. So this is very difficult to explain, but basically this framework contains with this framework, we can create something called a unit. The unit contains the whole model view and controllers inside the unit. And the unit can be enabled or disabled with just a flag. And yeah. And if any error occurs inside the unit, it doesn't throw the error to the parent application. It basically ignores the error and instead runs the original code on the parent application. So it's like A/B testing framework, kind of. The directory structure is very simple. We contain everything into one directory for each unit. So yeah, this is how we do. And the next topic is how we avoid being legacy. The application is like 7, 8 years old. It's been around since version 1.1, I think. And we keep upgrading it to the newest version of Rails. So how do we do this? How do we migrate this huge application? Of course, we need to split the application into small ones, but we do not do that. Our solution is we check, we make sure the response does not change between the versions. Let me explain. We run the actual user requests on new version and the old versions. And we compare response body HTMLs created by rake spec. For the first strategy, we use this. We call this a shadow proxy server, which simply copies the user request and sends it to both new server and old server. We put this proxy server in the real production server and process the real user requests on a new version server. And we don't return that response to the clients because this may include some errors. And then we check the logs to see if it's working correctly. And also we do this on each RSpec test. We save the response body and make a diff for each spec. I mean, we do something like this. After each, we save response body. This is very, very simple, right? Actually, we haven't published this onto the internet yet, so it's just an anonymous module. So if you would like to try this, just copy from my slides or or tell me it's open source. So anyway, we aggressively open source our hacks like this. Also, we contribute to Ruby, Rails, and these projects. Actually, the company, there are 3 Ruby committers in the company, employees. Which else company has 3 Ruby committers? Yes, Heroku, thank you. And NACL, I guess. So this is just an example. I very recently upgraded the application from 3.2 to 4.1, and I had to patch to all these frameworks and gems, and of course Ruby. So I mean, this is how we deal with open source community, I think. So this is my conclusion. Everyone is talking about microservices today because we need to convert our application to the microservices if our application becomes large. But did you know this huge application is still a monolith, and we're healthily developing on this monolith? I think Rails is really a great framework that can scale even this size of application with a little bit of crazy hacks. So, I'm sorry, I'm not saying that microservices are wrong approach. It can be a right approach in some cases, but it's not always right, as the internet claims. Instead of blindly believing that approach, I think we should you should always keep on doing this. Find what really is the problem and solve it. It doesn't have to be a microservice. In short, think before starting microservices architecture. Okay? It's done. Thank you.